Graphs associated with the frequency distribution table or FDT. Graphs can be constructed out of the information given in the FDT. Let us consider three of these graphs: bar graph, frequency histogram, and the frequency polygon. First is the bar graph. The classes or intervals are plotted in the x-axis, and the frequencies or relative frequencies are plotted in the y-axis. It is best used when data are discrete. Let us construct the bar graph of the scores in Table 1. So we will be needing the classes and the frequencies for the bar graph. This is now our bar graph. So the frequencies are in the y-axis and the classes or intervals are in the x-axis. Take note, there are spaces between the bars. There are spaces between the bars because our data are discrete data. And don't forget to add your title, Figure 1, Stat 211A, Quiz Course of Students. Reminder, when you are giving a title for your graphs, it should be written below the graph. Next is the frequency histogram. The true class boundaries or TCBs are plotted in the x-axis. The frequencies or relative frequencies are plotted in the y-axis. It's best used when data are continuous. Let us construct the frequency histogram of the weights in Table 5. So for the frequency histogram, we will be needing the true class boundaries and the frequencies. So for the true class boundaries or TCBs, we have the LTCBs and the UTCBs, the lower true class boundaries and the upper true class boundaries. If you notice here, the second LTCB is the first UTCB. The third LTCB is the second UTCB. The fourth LTCB is the third UTCB. Let us look at the graph or the histogram of this data. What have you noticed? First, there are no spaces between the bars. The bars are close together. This is because our data are continuous data. The frequencies are plotted in the y-axis, the TCBs in the x-axis. And don't forget to include your title in your graph. The last but not the least, the frequency polygon. The class marks or CMs are plotted in the x-axis and the frequencies or relative frequencies are plotted in the y-axis. It can be used for both discrete and continuous data. Initially, when plotting these class marks and the Freqs or the frequencies, the graph looks like a simple line graph. Since it is a polygon, it should be a closed figure. To do this, just subtract the value of C from the first class mark and add C to the last class mark, with these class marks having 0 frequencies. Let us construct the frequency polygon of the number of siblings in Table 4. So, we will be needing the class marks and the frequencies. Take note also that when we are constructing the polygon, the frequency polygon, we will be needing the value of C. What is the value of C in this FDT? Just go back to our class mark column. Before, when we constructed our FDT, to get the class mark, the second class mark, we simply added the value of C, okay, to the first class mark. So the second class mark is now equal to 4. And then if you get the second class mark, you added the value of C to the second class mark to get the third class mark. In this case, the third class mark is equal to 7. So what is now the value of C? We simply get the difference between the second class mark and the first class mark. So 4 minus 1 is equal to 3. Okay? So 7 minus 4 is equal to 3. 10 minus 7 is equal to 3. 13 minus 10 is equal to 3. So therefore, the value of C is equal to 3. We have 1, 2, 3, 4, 5 classes. We have 5 class marks also. So this is upon subtracting C from class mark 1 and adding C to class mark, actually this is 5. Both with 0 frequencies, we get these values. So this is now our first 5 class marks and their corresponding frequencies. So subtract C. C is equal to 3 from the first class mark. So 1 minus 3 is equal to negative 2. Okay. Then add C to the last class mark. So 13 plus 3 is equal to 16. Okay. And the frequency for this class mark is equal to 0. Same with the last class mark that we have produced. Just correct this again. This is class mark 5, not class mark 6. So this is now our frequency polygon. So this is our negative 2. This is our positive 16 class mark. This is our original class mark 1. Okay. Original class mark 1 and original class mark 5. This is equal to 13. This is our class mark with 0 frequency, our class mark with 0 frequency. So in this case, we now have a closed figure. This is now called a frequency polygon. So the frequencies are plotted in the y-axis and the class marks are plotted in the x-axis. Don't forget to add your title, figure 13, number of siblings among the respondents. Understood? If you have any question, please comment below. Thank you.